Alright, this is the last part of the exponentials review for Algebra 2 during week 3. The function g of x is equal to a b to the x represents exponential growth. Which statement is false? A has to be greater than 0. That means it's got to be positive, which will make it keep growing. That's true. B has to be greater than 1. That's also true. If you had negative exponents, you get fractions and stuff, so that has to be true. The y-intercept is 0, comma a. The y-intercept is when the x value is 0. Anything to the 0 power makes 1. So when x is 0, the y value is a. So number 2 is correct. The asymptote is y equals 0, unless you are adding or subtracting something onto the end of this to cause a vertical shift. Your exponential functions get closer to that 0 line, but will never hit it. Therefore, number 3 is correct, so our incorrect answer has to be number 4. The x-intercept is b comma 0. Well, the asymptote being y equals 0 means it's not going to hit a y value of 0, making 4 incorrect. Number 21 wants an exponential regression, so we go to stat edit. X is going to L1, y is going to L2, or in this case, A goes into L1, D goes into L2, so you can just type the fractions right into L1. The calculator will convert them to decimals, that's fine. And 1, 2.25, 3.25. Stat over to calc, number 0 for exponentials, so that's what we have to write down for work. Stat calc number 0. Nearest thousandth is 3 decimal places, so y equals 1.223 times 2.652 to the x is our equation. And that's it. They just wanted the regression, so that'd be a simple 2-point question on the regents. Make sure you write down your button presses. Alright, number 22. Researchers in a local area found the population of rabbits where the initial population of 20 grew continuously at the rate of 5% per month. So rabbits are going to equal, remember continuously is pert, so 20 e to the 0.05 t. The fox population had an initial value of 30 and grew continuously at 3% per month. So foxes are 30 e to the 0.03 t. Find the nearest tenth of a month, how long it takes for these to be equal. Alright, so we set them equal to each other. Alright, well, we have e's on both sides, and algebraically, this is going to be a bit difficult to do. So what I suggest is that we put it in our graphing calculator, both of those. And so we've got 20 e to the 0.05 x. Make sure the 0.05 x is in parentheses. And then we have 30 e parentheses 0.03 x. And now the thing is, they want to the nearest tenth of a month. So this is where you're going to go to table set, which is the second and window key. And that second option where it says triangle, that is a delta, Greek letter delta, and that means change. So they are asking you, how do you want your table to change? Well, we want our table to show tenths. Tenths is 0.1, so I'm going to change that to a 0.1. I'm going to go back into my table, and now I can see decimal values. So I am looking for when both of those are equal. So I'm scrolling, and I might be scrolling for a very long time. All right, I'm in the 7s so far. Now I'm in the 12s. We're catching up. Alright, I'm in the 18s and they're getting close. So I'm going to slow down here. Alright, so at 19.5 months, I have 53.023 and 53.85. And at 19.6 months, I have 53.289 and 54.012. Alright, so maybe I'm not close enough yet. Okay, so that wasn't close enough yet. I was looking for where they crossed. Alright, so I have at 20.3, 55.187 and 55.158. Gosh darn it, sorry about that. Alright, so 55.187 and 55.158. And at 20.4, I have 55.464 and then 55.323. So at 20.3, the first column, the rabbits, are smaller than the foxes. And then at 20.4, the rabbits are bigger than the foxes, which means somewhere in there they changed. So I just got to figure out which one of these is closest. So if I take 55.187 and subtract 55.158, I'm going to get 0.029. And if I subtract these guys, I'm going to get 0.141. That says 20.3 are the values that are closest together. So it takes 20.3 months for those populations to be equal. Explain why 81 to the 3/4 is equal to 27. Well, you take the 4th root of 81. Remember, denominator is root, and that equals 3. And then you cube the 3, or you can say do 3 to the 3rd power, and that gives you 27. Number 24. For x is greater than or equal to 0, which equation is false? Alright, so we're making rational exponents and radicals. So this one is x to the power over root. This one is x to the power over root, power over root, power over root. So 3 of them have an x to the 3/4. One of them is to the 4/3. Alright, so let's just go through and systematically figure them out. When we have a power to a power, we multiply. 3/2 times 2 is going to be a 3. So I'm thinking that's the one right there. 3 times a 4th is 3/4. That one works. 3/2 times 1/2 is 3/4. That one works. 2/3 times 2 is 4/3. That one works. So our answer is number 1. They're not equivalent. Number 25, a savings account has an initial value of 500. The account grows at 2% interest rate compounded n times per year according to the function below. Which statement about the account is correct? As the value of n increases, the amount of interest per year decreases. You could fill in an n Okay, so n is the number of times it gets compounded a year. So you could say, all right, well, what happens if it gets compounded 5 times a year? Go put that in your calculator and get an equation. And then make up a different one. So let's compound it more. Instead of 5 times per year, let's compound it 12 times per year. And go put that in your calculator. And it says that if the n is bigger, you're going to get less interest. And when you put those into y equals, you're going to find out that that's just not true. The more you compound interest, the more money you make, and that gives you a bigger pot to earn interest on. So no, the more times a year you compound it, the more money you're going to make. So that's not correct. As the value of n decreases to 1, the amount of interest per year increases. Well, that pretty much says the same thing as number 1, but in reverse. So they're saying as the n gets smaller, you earn more interest. No. Okay, the more times you compound interest, the higher the interest rate. So it's either number 2 or number 4, or sorry, number 2 or number 4. Number 2 says as the value of n increases, the value of the account approaches this equation. And as the value of n decreases towards 1, the account approaches this. Well, you could go put this in your graphing calculator. It says as the value of n increases, so I would compare it to the second one that you did over here because your n's kind of big. And you're going to notice that those tables are pretty darn close. So I would pick that one. But even without the calculator, if you look at this function right here, you are subtracting inside that parenthesis. And subtraction is exponential decay, which means your amount is going down. But we are growing at 2% per year, so it can't be number 4 because it's a decay, which means by process of elimination, it's got to be number 2.